Okay, these notes are Lewis structures and resonance. What is resonance? Resonance is when you can make a double bond in more than one place in a Lewis structure. In actuality, that double bond is not static. In other words, it moves, doesn't stay still. We show this by drawing all of the resonance structures, which are all the possible places the double bond can be. Okay, let's look at O3. What we're going to do is we're first going to draw the Lewis structure for O3. So there's 3 O's. It doesn't matter what the central atom is. So I'm just going to draw one here, and one here. And draw a single bond between. Now, when I stick all of the electrons around it, oh yeah, first we better figure out our number of electrons. 3 times 6 is 18. So we really have only 18 valence electrons available to us. Okay, so now let's count the ones we've drawn. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we have 20 valence electrons here. Well, we're 2 over. Now remember what I told you, for every 2 that we're over, we have a double bond. So now, where do we put it? Oh my goodness. I don't know where to put it, do you? Well, actually, you can put it anywhere. So it doesn't matter where you put it. You can put it on the left or the right. Because actually, can't talk today. Actually, it goes on both sides. So let's draw what are called resonance structures. Okay, so I'm going to draw 2 sets of the three O's. So we have one here, and here. And then another set. Yeah, I kind of draw them up like that. When we get to molecular geometry, you're going to realize that O3, this is how it actually looks. This is kind of closer to the geometry. But that doesn't matter right now. Okay, so we already figured out it needs one double bond. So I'm going to put the double bond on the left one there first. Now I'm going to fill in with all the rest of the electrons. So this oxygen has 2, 4 and needs 4 more. Oops. Actually, let's draw dots, not dashes. I don't know what's going on with my pen. So I'm going to draw this and this, and then this and this. Okay, so now this middle oxygen needs 2 more, and this end oxygen needs 8 more. So let's double count. 1, 2, let's hit 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, now, because that double bond moves, because it can also be drawn on the right, and your resonance and your structure for O3 is still correct. So what happens is this double bond goes from left, right, left, right, left, right, goes back and forth. That double arrow indicates that both structures occur. So the double arrow shows that both structures occur. So in other words, that double bond is flipping sides constantly. Going back and forth, back and forth, back and forth. Okay, let's try another one. Okay, let's try SiO3. Now, let's go ahead and calculate our valence electrons. So, silicon has 6 plus, or no, sorry, silicon has 4. I cannot count today. Okay, so silicon has 4, and 3 times 6, which is 18. So this comes out to be 24 electrons. Okay, so now if you do the 6n plus 2, you get 6 times 4 plus 2 equals 26 valence electrons. So we're 2 short, so we know there's going to be 1 double bond. There's 3 oxygens. Silicon, like carbon, will be the middle, will be the center atom. All 3 oxygens will be nearby, or will be around it. Where do I put that double bond? Well, you put it all 3 places, just in different times. So we'll draw one here. And I'm going to start the double bond on this side first. Okay, and then draw all of our electrons. And before I draw the next structure, I want to count my electrons to make sure that I'm doing this right. So I got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, so that's the first structure. Now the next one, I'm going to draw the silicon with the oxygens, only I'm going to put the double bond in the middle. So I put the appropriate number of electrons around it. Okay. Now the next one, I'm going to draw with the double bond on the third side. See how I've hit all oxygens? Because that double bond moves between all three oxygens. So these are the 3 resonance structures of silicon trioxide. Okay? And it's really easy to figure out how many resonance structures you're going to be drawing. If you have 3 oxygens, there's going to be 3 resonance structures. Okay? Usually they go between oxygens only. Oxygens and sulfurs are the 2 atoms that like to double bond. Most of the time you don't get too much else. Every once in a while it might be between carbons and silicon, but most of the time it's oxygens and sulfurs. Okay, last example. NO2Cl. So let's figure out our electrons. And we have 5 plus, now I know oxygen has 6, so 2 of them has 12, plus 7, and that gives me, let's see if I can add 19, 20, 21, 22, 23, 20, 24 electrons. Now if I do the 6n plus 2, just like the other one, it's going to be 26, which is 2 off, which means, well here, let me just show you. 6 times 4 plus 2 is 26. Oops. So we're 2 off, so I know that there's at least 1 double bond. Well, there's a double bond. Now, there's 2 oxygens, so I already know that there's only going to be 2 resonance structures. So now, which one's the central atom? Well, if you look at your rules from before, carbon's usually central, but there's no carbon. There's a nitrogen, 2 oxygens, and a chlorine. One of the other rules is whichever one can make the most bonds. So nitrogen can share out 3 electrons, so it can make 3 bonds. Oxygen can only make 2 bonds, and chlorine will only make 1. So the central atom is going to be your nitrogen. So we're only going to draw 2 resonance structures because there's only 2 oxygens. Because remember, chlorine will never double bond, not when it's on the outside. So I'm going to first draw my double bond here. I'm going to put all of my dots around it. Okay, and I'm going to double check. I need to count my electrons to make sure I'm doing this right. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So now I'm going to put the double bond on the other side. And then put the appropriate amount of dots. Okay? So that's the resonance structures for NO2Cl. That's about it. We'll have about 5 or 6 of them that you'll have to do in class tomorrow. We'll do a little warm-up first, but it's not that hard. It's just drawing Lewis structures with moving double bonds. It's pretty much about it. So hopefully you guys understand this. So I'll see you tomorrow. Bye.